This video covers one of the sections in the appendix on some tricky factoring techniques. When you look at this problem, the first thing that pops into your head probably is to distribute the two and then combine your like terms, which is perfectly legal and viable. It's not always a great idea because sometimes when the problems are a lot more complicated, you are left with a huge polynomial that you just don't know how to factor. So instead of doing that, we're going to follow some of these new techniques. And what I notice here is x squared plus 8x plus 16 is a perfect square trinomial. And it just happens to be the perfect square trinomial of that x plus 4. So I would like to write this trinomial as the quantity x plus 4 squared minus 5 times that x plus 4. And the reason that is beneficial is that this now can be thought of like a quadratic form. And I'm going to use substitution here and say let y equal x plus 4. Just because when we make that substitution, it's going to be easier for us to factor this polynomial. So if y equals x plus 4, this just becomes 2y squared minus 5 times y. Now that is really easy to factor. All we have to do is take out the GCF, which is y, and we're left with y times 2y minus 5. Now be careful you're not finished with that because this polynomial is in terms of y. We need to get it back in terms of x. So we've got to go back and kind of like unsubstitute the y value as x plus 4. So in place of that y, I'm putting x plus 4. And because it's a binomial, I am putting it in parentheses. Also, for this parenthesis, I'm going to go with a big bracket because I see I'm going to have to do some substituting of a binomial in for that y, and that's going to get this kind of complicated if I don't use the big bracket there. So big bracket there for this position right there, 2 times the quantity in parentheses x plus 4 minus 5. Close off that bracket. So x plus 4 stays in the front, and inside here I'm going to distribute the 2 to give me 2x plus 8 minus 5. Keep the x plus 4 in the front, and then combine inside here, and I'm going back to regular parentheses now, and this is just 2x plus 3. The only reason this works out so nicely is because this perfect square trinomial is the perfect square of that binomial. These next few problems are ones that you might have to factor in calculus. So I'm going to show you a technique for doing that. You may look at this one and be tempted to distribute and combine and then factor, and that will work just fine on this problem, but you'll see as we get into the more complicated ones, you don't want to do that. So here's what we want to do. We want to organize this so that your monomial is clearly in the front, followed by whatever binomial or binomials you have. So I just recopied that. Over here, I want to put the 6 in front because that's what we're used to looking at. Now we need to factor out the GCF, and one way to do that is draw lines as if you're getting ready to divide. And what you want to write down here is your GCF, and look at it piece by piece. There's a 6 here, there's a 6 there, therefore 6 must be part of my GCF. Then I see the x with the x squared, and remember when you're looking at terms like that, you're going to take the least power that's there. This is x to the first, this is x squared. Sounds kind of funny. We're finding the greatest common factor, but we end up taking the least power that's there because that's the one that's in common. So that is my GCF. There's no way 4x plus 4 is part of my GCF because there is no binomial over here. This is just a little tool to help us do the canceling in a minute. We need to take that 6x and write it down here also so that it leads the factoring. Now we can do the canceling a little more easily. You don't have to do this dividing by 6x. I think for most people, though, it makes it easier to see this term by term what cancels. So the 6's cancel, the x's cancel, and all you're left with right here is 4x plus 4. Plus, and that's this plus right there coming down, the 6's cancel, and for our exponents, of course, that's x to the first. We're going to keep the base, which is x, subtract the exponents, making that x to the first, and then rewrite your 6x. Within the parentheses, combine your like terms, gives you 5x plus 4, and that is your factorization, which you certainly could have distributed and combined and come up with this also. When you look at this, it's the same idea. We want to organize this so that your monomials are out front. So this is 6, and then the only binomial I have for this part is 5x plus 7 squared, plus, I want to look at this whole term, and I want to organize it so that all of the monomials out front, so 6 times 5 is 30. I also want to have my binomials in the same order just to make it easier. So this would be 5x plus 7 because the thing that comes after the monomial here is the 5x plus 7. And then over here is 6x plus 5. Then, same deal, I'm going to draw a line underneath each term and look at it piece by piece to decide on what the GCF is. I've got a 6 here, and 6 is a factor of 30, so that's a GCF for the numbers. We've got a 5x plus 7 squared and a 5x plus 7. As far as greatest common factor goes for those two terms, you take the least power that's there. So the GCF for that is 5x plus 7, and it's 5x plus 7 over here. So that is my GCF. And be sure you don't leave your GCF hanging as this denominator. We're only doing this denominator thing just as a tool to help us do our canceling. The 6 times 5x plus 7 is our GCF, and it needs to be out front. Then I'm going to go with the big bracket, just because I know I've got a lot of combining I'm going to have to do in a minute. So let's go over here and cancel out. 6 cancels with 6. This is a 1 right here. So using your exponent laws, there is our common term. Exponent of 2, exponent of 1. We keep the base and we subtract the exponent. So what's inside here is 5x plus 7. To the first, if you want, I'm just emphasizing the fact that what I used right there was the exponent law. I'm going to erase that because I really don't need that right there. Then I come over here, do the same kind of canceling. 6 goes into 35 times. And then the 5x plus 7's cancel. That's great. But what you're left with is this binomial, 6x plus 5. And then you see why I like to have the big bracket there, because within here I've got to do some simplifying. So the 6 times 5x plus 7 hangs out in front. I still have the big bracket for now. 5x plus 7 comes on down. But over in this part, distribute the 5 is 30x plus 25. So bring the 6 times the 5x plus 7. And then I'm going back to regular parentheses because within here I could do 5x plus 30x is 35x. And 7 plus 25 is 32. And that is my complete factorization for this up here. And taking a look at this, first thing you want to do is get things organized. So I've got a plain old 6 out front. And I'm just leaving this in the order it started with. X plus 3 to the 5th, x minus 5 to the 9th. But over here, I want to bring the 9, the plain old number, in the front. Then I'd like to have the x plus 3 to the 6th term second, because it's second over here. And then the x minus 5 to the 8th. Draw our lines, bit by bit, see if we can find the GCF. We have a 6 here, we have a 9 there. The GCF for 6 and 9 is 3, so that's in both of the denominators. X plus 3 to the 5th, x plus 3 to the 6th. The common factor is x plus 3 to a power, and the power will be the least power we have between the two of those. So that is x plus 3 to the 5th, and I'll put that in the bottom down here. And then for these two, they're both x minus 5s. So x minus 5 to a certain power. You take the least power that's there, which is why I'm going to choose x minus 5 to the 8th, x minus 5 to the 8th. So that denominator is my GCF. So I need to write it down in the front. X plus 3 to the 5th, x minus 5 to the 8th. And that stays in front of big brackets. And then I'll start working on what I can cancel. So it's important to remember that that GCF that you've put in the bottom of your polynomial up here has to come down right here as your GCF, because it is a major part of your factoring. Then I can start canceling. 3 goes into 6 twice, so there's a 2 coming right here. X plus 3 to the 5th, x plus 3 to the 5th, that's easy. It cancels totally out. Here we'll use our exponent law, which says keep the base, which is the quantity x minus 5. Subtract the exponents. 9 minus 8 is 1, which I don't need. I will erase that. And then take a look at the next part. 9 divided by 3 is 3. I'm going to jump over here just for a second because I know that cancels. X minus 5 to the 8th, x minus 5 to the 8th. Let's just get rid of those. Now between these two, x plus 3 is my common base there. And my exponents here, 6 minus 5 is 1, but I'm not going to write it. So now I'm just going to save some time and just deal inside here for right now. Distribute your 2 is 2x minus 10. Distribute the 3 is 3x plus 9. So within that bracket, I can put my 2x plus 3 together to get 5x. Negative 10 plus 9 is negative 1. So that's that part. Now I can bring down this part 3 times x plus 3 to the 5th times x minus 5 to the 8th. So this is my complete factorization of the original polynomial. And of course, what order you put this in doesn't matter.